Three-dimensional geometry, shortest distance between two lines. So this is a very important topic as far as CBSE board examination is concerned. A 5-marker or 3-marker questions can be expected from this topic. So there are two types of shortest distances. Number one, shortest distance between skew lines, and number two, shortest distance between parallel lines. So look at this. Two lines which are neither parallel nor intersecting are called the skew lines. So they will be in two different planes, because if they are in the same plane, if they are coplanar, they will intersect. So it will be in two different planes. So they are non-coplanar. Okay, there are two forms. Number one, vector form, and number two, Cartesian form. So when the equations are written in terms of position vector of each point, it is called the vector form. And in terms of Cartesian coordinates, it is Cartesian form. So let's see the vector form. In vector form, equations are like this. Equations of lines are like this. The first line L1 is vector R is equal to vector A1 plus lambda times vector B1, where lambda is a constant. And the second line L2 is vector R is equal to vector A2 plus mu times vector B2. So these type of two lines, vector forms can be written like this. So this is a unique formula for finding shortest distance. We have to take the parallel vectors from these lines. The parallel vectors are immediately after lambda and mu. You can see two vectors, vector B1 and vector B2. These two are called the parallel vectors. So first of all, we have to take the cross product of these two. Vector B1 cross B2 dot, it is dot product then the difference of the two vectors, vector A2 and vector A1. Vector A2 minus vector A1 divided by modulus of the cross product, modulus of B1 cross B2. So this entire thing should be in a modulus, because it will be a positive quantity. Being distance, it should be a positive quantity. So if Cartesian form is given, you have to convert that Cartesian form into vector form, and you will use the same formula, which means one formula is enough to study to find the shortest distance between two lines. That is this formula, modulus of B1 cross B2 dot A2 minus A1 by modulus of B1 cross B2. Now let's see how to convert Cartesian form to vector form. So if you get a Cartesian form, for example, L1 is x minus x1 by A1 and is equal to y minus y1 by B1 is equal to z minus z by C1. You can easily convert it into Cartesian form. We have to take the points x1, y1, z1 in place of vector A1. Then the parallel vectors direction ratios A1, B1, C1 like this, lambda times A1 I cap plus B1 j cap plus C1 k cap. So it is of the form vector A1 plus lambda times vector B1. Second line also we can easily convert, and we get vector A2 plus mu times vector B2. Now let's see the sums based on shortest distance. First question is a vector form. So it is a direct form. Vector R is I cap plus 2j cap plus k cap, that is vector A1 plus lambda times, so this is vector B1. And second is vector A2 plus mu times vector B2. So when you get this type of a question in the examination, it won't be written it is skew line or parallel line. We have to check like this by taking the coefficients. It's 1 by 2 and then minus 1 by 1 and 1 by 2. If these ratios are equal, the lines are parallel. If they are different, the lines are skew lines. So here we check this proportionality. So 1 by 2, the highlighted parallel vectors, 1 by 2, then minus 1 by 1 and 1 by 2, they are different. So the lines are skew lines. So when you get this type of a question in the examination, first of all you have to check this proportionality. And then we have to write vector A1 from here, vector B1, then vector A2 and vector B2. So we have to find out vector B1 cross B2 vector A2 minus A1 and vector modulus of B1 cross B2. So let's see how to find out these three quantities for the shortest distance. The first step is vector A2 minus A1, the difference between these two. So this is vector A2 minus of this one is vector A1. So when you subtract, we get 2 I cap minus I cap minus 3 j cap minus 2 k cap. Next is cross product. Cross product is a determinant. The first row of the determinant is I cap, j cap, k cap. Second row is coefficient of vector B1. Look at here, coefficient of vector B1, 1 minus 1, 1. So that should be written as the second row. And coefficient of vector B2 is 2, 1, 2. It is the third row. And then you will open the determinant I cap into, by removing this row and this column, minus 2, minus 1. Then alternate positive and negative sign, minus j cap into removing the first row and second column, 2 minus 2 plus k cap into 1 minus minus 2. You will get B1 cross B2. And then modulus of B1 cross B2, it is root of minus 3 square plus 3 square. It is root of 18 or 3 root 2. Then we will write the formula like this: shortest distance, and substitute in place of B1 cross B2 dot product A2 minus A1 by modulus of B1 cross B2. All of you know dot product is multiply the coefficient of I cap, that is minus 3 into 1, then plus, because I dot I is 1, there is no j cap, means 0 j cap, that will be 0, and then k cap is 3 into minus 2, and that one when you simplify we get modulus of minus 9 by 3 root 2 or 3 by root 2. Modulus will convert it into positive quantity, and the answer is 3 by root 2. When you rationalize the denominator, we get 3 root 2 by 2 units. Look at another question. It is a combined form. Last question we could separate it out, but this question is combined form. So we have to open the bracket like this: 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap. So when you open the bracket, we get 1 I cap minus t I cap plus t j cap minus 2 j cap plus 3 k cap minus 2 t k cap. And then we can combine I cap minus 2 j cap plus 3 k cap. The constant in place of lambda, here it is t. So t is taken outside, t into minus I cap plus j cap minus 2 k cap. It is in standard form, vector A1 plus t times vector B1. The same way, second line also can be converted. Vector A2 plus another constant s times vector B2. In this question also we have to find out three quantities: vector A2 minus A1, then B1 cross B2 as determinant, then modulus of B1 cross B2, then we will substitute in the shortest distance formula. Now let's see the shortest distance between the lines. Here the lines are in the form Cartesian equation. Cartesian form is given. Cartesian form is x plus 1 by 7 is equal to y plus 1 by minus 6 is equal to z plus 1 by 1. And x minus 1 by 1 is equal to y minus 5 by minus 2 is equal to z minus 7 by 1. First of all, we have to write the standard form x minus x1 by a1. So to write that form, x minus minus 1 by 7 is equal to y minus minus 1 by minus 6 is equal to z minus minus 1 by 1. X minus 3 by 1 is equal to y minus 5 by minus 2 is equal to z minus 7 by 1. So we don't have to use separate formula for Cartesian form. The same vector form formula can be used. For that one, you will convert the Cartesian form to vector form like this. Vector r is equal to, take out the points from the numerator of the Cartesian form, that is minus 1, minus 1, minus 1, and you will put in this form minus 1 I cap plus minus 1 j cap plus minus 1 k cap, that is our vector a1, plus lambda into, then the denominators 7 minus 6 1, 7 I cap minus 6 j cap plus k cap. So that is vector b1. The same way, second one also can be written vector a2 plus mu times vector b2. So after getting all these, we have to check the skew lines. 7 by 1, minus 6 by minus 2, 1 by 1 from the parallel vectors. They are different. So these are skew lines. So then we have to find vector a2 minus a1. Then b1 cross b2 as determinant. First row is I cap, j cap, k cap. Second row from vector b1, 7 minus 6, 1. Third is 1 minus 2, 1. And then we have to open the determinant. b1 cross b2 we found. Then modulus of b1 cross b2 is root of minus 4 square plus minus 6 square plus minus 8 square, root of 116. Then we have to write the shortest distance formula and substitute. Take out the dot product like this. Multiply the coefficient of I cap dot I cap is 1. Multiply the coefficient of j cap and multiply the coefficient of k cap. And then by root of 116, modulus, that will convert it into positive. So the answer is root of 116 units. When you reduce it to root 29 units. See the next question, find the shortest distance between the lines. Here Cartesian forms are written, but there is a slight difference in this Cartesian form. In the first one, last term is equal to z. That one we can write z minus 0 by 1. In second Cartesian form, it is a semicolon or comma z is equal to 2. That comma z is equal to 2 should be written as z minus 2 by 0. Because if you equate it to a constant lambda, z minus 2 by 0 lambda, z minus 2 is 0, z will be equal to 2. So this is very important. Like this comma z is equal to 2 should be connected to the Cartesian form like this is equal to z minus 2 by 0. Now the same form as there in the last question, you can write the corresponding vector form like this. Vector r is 1 I cap minus 1 j cap plus 0 k cap plus lambda into 2 I cap plus 3 j cap plus k cap. And second one also the same way, minus 1 I cap plus 2 j cap plus 2 k cap plus mu into 3 I cap plus j cap plus 0 k cap. So we got vector a1, vector b1, vector a2, vector b2, checking for skew lines and then finding out vector a2 minus a1, b1 cross b2 and modulus of b1 cross b2, then substitute there in the shortest distance formula. Next is shortest distance between parallel lines. For parallel lines, the parallel vectors will be either same or proportional. So here you can see vector r is equal to vector a1 plus lambda times vector b, and second line is vector a2 plus mu times vector b. So there is no difference like b1, b2 as there in skew lines. These two are same vectors or proportional vectors. So in the formula also that will reflect shortest distance is modulus of, in place of that b1 cross b2, it is vector b. Vector b cross vector a2 minus a1 by modulus of vector b. And here we have to check first of all parallel line. For example, a question like this, I cap plus 2 j cap plus 3 k cap plus lambda into I cap minus j cap plus k cap, 2 I cap minus j cap minus k cap plus mu into minus I cap plus j cap minus k cap. So look at the highlighted parallel vectors. Shortest distance between parallel lines. This is the formula. Vector r is vector a1 plus lambda times vector b. Vector r is vector a2 plus mu times vector b. Here the parallel vectors are the same. Shortest distance is modulus of vector b cross vector a2 minus a1 by modulus of vector b. So look at this question here. Find the shortest distance between the parallel lines. Here you can see the highlighted vectors 1 by minus 1, minus 1 by 1, 1 by minus 1. All these are equal. When they are equal, these ratios are equal, the lines are parallel. and when after finding out parallel, we have to make these two vectors same. For that, from the second parallel vector, we have to take out minus outside as a common factor, like this, minus mu into vector b. And now we can easily compare these and write vector a1, vector a2 and vector b. After this, we will find out vector a2 minus a1 and then vector b cross a2 minus a1. So that will be like this. The first row is I cap, j cap, k cap. Second row is from vector b, 1 minus 1, 1. Third is from vector a2 minus a1, 1 minus 3 minus 4. We will operate that and we get this as a vector. Then after that, we will substitute it into the shortest distance formula. So this is the formula. Before that, vector modulus of vector b we found. And when we substitute, numerator is a vector. We have to get the answer as a scalar because this is a distance. So we will use this formula. Modulus z1 by z2 is modulus z1 by modulus z2. You have studied this in complex number. It is applicable for real numbers as well. So it will be modulus of 7i cap plus 5j cap minus 2k cap by modulus of root 3. So that will come like this, root of 7 square plus 5 square plus minus 2 square, that is root 78 by 3, root of 78 by 3, root 26 units. So we have studied in this session how to find out shortest distance between skew lines and the parallel lines. For both one, it will be given us simply find out the shortest distance between the lines. We have to find out by checking the proportionality whether the lines are skew lines or parallel lines. For parallel lines, we will use this formula, vector b cross vector a2 minus a1 by modulus of vector b. And for skew lines, you will use this formula, modulus of b1 cross b2 dot vector a2 minus a1 by modulus of vector b2. For skew lines, you will use this formula to find out the shortest distance, modulus of vector b1 cross b2 dot vector a2 minus a1 by modulus of vector b1 cross b2. Whether it is vector form or Cartesian form, this formula is enough. If you get Cartesian form, you will convert it into vector form and you can easily use this form.